In this example, it says it was reported that the average rent for office space was $17.35 per square foot in the Niagara region. A real estate agent thinks that this is not correct. She decided to test the claim and selected a random sample of 15 rental offices and found the mean rent to be $18.73 per square foot, with a standard deviation of $3.74 per square foot. At alpha equal 0.05, was she right to question a reported figure? Okay, so once again, in this question, you can see, first of all, that the sample was less than 30, so n is less than 30, which implies using the t-value. So I always suggest starting with this statement, so we know exactly what we're working with. So we're going to use our t-table. And then secondly, we're going to state our hypotheses. Now you see that in this case, there was no direction given. It just says it was reported to be $17.35 per square foot. So the rent was this value here. So you can see then, as a result, that there is no direction given in the question. So the mean either equals $17.35 per square foot, or it does not equal that value. Okay, so as a result, that means we have a two-tail scenario. Okay, so that's our first step, putting together the hypotheses, and then secondly, we are now going to put together our normal curve with our mean in the center, and we're going to draw our two tails. And once again, in terms of the area, not that you really have to worry about this, but this would be alpha over 2, which is 0.05 divided by 2. Okay, likewise, alpha over 2 is going to be the same. But because our table actually gives us the different combinations for this error, all we have to do is go to the table and look for the proper column and the proper row, and where those two values intersect, that's going to be the critical value we're going to use. So once again, with this here, we know that we are looking at degrees of freedom, 15 minus 1, which is 14. So in our table, we're going to need a two-tail with alpha 0.05 and degrees of freedom 14. Okay, so let's take a look and see what is that value going to be. So once again, in terms of finding the right column, first of all, it's a two-tailed test. Okay, so we're interested in looking at these values. The level of significance was 0.05, so this is the column we're going to be looking at. And degrees of freedom was 14. So where those two values intersect, that is going to be the critical value, so 2.145. So the value is going to be 2.145 on the right, and on the left, it's a negative 2.145. The next step is to do the test and to use t is equal to the sample mean minus the population mean divided by standard deviation divided by square root of sample size. And let's put down what we know in this case. So from the question, it was 18.73 minus 17.35 divided by $3.74 and divided by the square root of the sample size, which was 15, and I got the following values, which then gives us 1.429068.721, and now we can round to 3 decimal places, so approximately 1.429. Okay, so based on this information, let's go plot that on our curve, and it's going to look something like this. It's 1.429. It's positive as well, so we know it's going to be somewhere along here. Once again, that's our test. Okay, and now we can make our decision. So you can see that it falls in the non-critical region, right? We do not reject if it falls in this area here. So our decision then is do not reject our null hypothesis. In other words, we're not going to reject this. We're not going to reject it. In other words, we're going to assume it to be correct. I want to mention, even though our sample of 15 office spaces gave us a value that is above the average, the question is, or the thing is that when we factor in the size of the sample as well as the standard deviation, we're just not far enough away from 17.35 to say that they are actually different. Okay, so that's a very nuanced thing that I want to mention. So even though our sample looks like it's above average, it's still not far enough away when you factor, like I said, standard deviation, the size of the sample. So the last thing we're going to do then is actually state our conclusion once again and see what you come up with, and we'll compare notes. And the conclusion I came up with is that our sample data indicates the population mean rent is not significantly different than $17.35 per square foot. And once again, I'm basing my conclusion on our alternative hypothesis. With that said, I'm going to move on to the next example in the next video.